Our friends at the Highlands Museum and Discovery Center in Ashland, Kentucky, asked a very good question. Why is it dark in space? That question is not as simple as it may sound. You might think that space appears dark at night because that is when our side of Earth faces away from the sun as our planet rotates on its axis every 24 hours. But what about all those other faraway suns that appear as stars in the night sky? Our own Milky Way contains over 200 billion stars, and the entire universe contains over 100 billion galaxies. You might suppose that that many stars would light the night sky like daytime. Until the 20th century, astronomers didn't think it was even possible to count all the stars in the universe. They thought the universe went on forever. In other words, they thought the universe was infinite. Besides being very hard to imagine, the trouble with an infinite universe is that no matter where you look in the night sky, you should see a star. Stars should overlap with each other in the sky like tree trunks in the middle of a very thick forest. But if this were the case, the sky would be blazing with light. The problem greatly troubled these astronomers and became known as Olbers' paradox. A paradox that is a statement that seems to disagree with itself. So, to try and explain this paradox, some 19th century scientists thought that dust clouds between the stars must be absorbing a lot of the starlight, so it wouldn't shine through to us. But later, scientists realized that the dust itself would absorb so much energy from the starlight that eventually it would glow as hot and as bright as the stars themselves. Astronomers now realize that the universe is not infinite. A finite universe. That is, a universe of limited size. Even one with trillions and trillions of stars just wouldn't have enough stars to light up all of space. Although the idea of a finite universe explains why Earth's sky is dark at night, other causes work to make it even darker.
Thinking of doing the right thing or wrong thing. For example, if a task is well designed, people are likely to do the right things, otherwise they are prone to make mistakes, distractions, people will forget they are in the middle of doing something. For example, we usually forget to take the original copy after using the copy machine if something disrupts the thinking process. There are two strategies to avoid making mistakes. The chance of making mistakes depends on the quality of task design, so you could polish the instructions. If the task is well designed, people are likely to do right things. People are likely to make mistakes. Remember to avoid distractions. The people who do photocopying might leave the original copy in the machine if the thinking process is disrupted. Climate change. Some adverse effects of climate changes to agricultural productions. Some lands are unsuitable for growing crops. There will be millions of people facing hunger in Africa in the future. Climate change will result in less production and less food. It is difficult for developing countries to deal with climate change due to their financial status and other issues. There are many people living in hunger, especially in Africa. The climate change has devastating effects on world economy. The tropical areas on Earth are dry and hot, and are originally not suitable for food production. The change of the climate leads to extreme weather conditions such as flood and hurricane, which exacerbates the food production. As a result, it leads to a continuous decline in food supply annually around 10 to 17%. And this trend is perceived to be continue in the future by 2070. The regions suffering the most will be some African countries.
Wilson came then from a different world, and he became the focal point of a broad mainstream American culture that thought that modern literature and wanted modern literature to be able to be read and appreciated by ordinary people. They were not modernists in an abstract sense, and certainly some of them, like T.S. Eliot and Faulkner, were too difficult for some of their writings to be read by ordinary people, but this was a world before the division between the brows or between elite or whatever had established itself as part of our consciousness. Wilson was a major player in the successful effort of his generation to establish at the heart of American life an innovative literature that would equal the great cultures of Europe. And he knew that the great cultures of Europe were there. He was not a product of a narrow American studies kind of training at all. He joined a high artistic standard with an openness to all experience and a belief that literature was as much a part of life for everyone as conversation. He thought that Proust and Joyce and Yeats and Eliot could and should be read by ordinary Americans and helped that to happen. Wilson was a very various man. Over a period of almost 50 years, he was a literary journalist, an investigative reporter, a brilliant memoirist, and dedicated journal keeper.
And so this is one picture that probably you all know what it is when you see it. It's a familiar looking image. It's something that probably we all have some personal experience with, right? This is a chest X-ray that would be taken in your doctor's office, for example, or a radiologist's office. And it is a good example of biomedical engineering in that it takes a physical principle, that is, how do X-rays interact with the tissues of your body, and it uses that physics, that physical principle, to develop a picture of what's inside your body. So to look inside and see things that you couldn't see without this device. And you'll recognize some of the parts of the image. You can see the rib cage here, the bones. You can see the heart is this large, bright object down here. If you're have good eyesight from the distance that you're at, you can see the vessels leading out of the heart and into the lungs, and the lungs are these darker spaces within the rib cage.
The first inhabitants in Australia were the ancestors of the present indigenous people. Whether these first migrations involved one or several successive waves and distinct peoples is still subject to academic debate, as is its timing. The minimum widely accepted time frame places presence of humans in Australia at 40,000 to 43,000 years before present, while the upper range supported by others is 60,000 to 70,000 years BP. In any event, this migration was achieved during the closing stages of the Pleistocene epoch, when sea levels were typically much lower than they are today. Repeated episodes of extended glaciation resulted in decreases of sea levels by some 100,150 meters. The continental coastline therefore extended much further out into the Timor Sea than it does today, and Australia and New Guinea formed a single landmass known as Sahul, connected by an extensive land bridge across the Arafura Sea, Gulf of Carpentaria and Torres Strait. The ancestral Australian Aboriginal peoples were thus long established and continued to develop diversity and settle through much of the continent. As the sea levels again rose at the terminus of the most recent glacial period some 10,000 years ago, the Australian continent once more became a separated landmass. However, the newly formed 150 km wide Torres Strait with its chain of islands still provided the means for cultural contact and trade between New Guinea and the northern Cape York Peninsula. During the 1970s and 1980s, around 120,000 Southern Asian refugees migrated to Australia. During that 20 years, Australia first began to adopt a policy of what Minister of Immigration A.I. Grassby termed multiculturalism. In 2004–5, Australia accepted 123,000 new settles, 19 a 40% increase over the past 10 years. The largest number of immigrants, 40,000 in 200,405, moved to Sydney. The majority of immigrants came from Asia, led by China and India. If your recruiting efforts attract job applicants with too much experience, a near certainty in this weak labor market, you should consider a response that runs counter to most hiring managers' motto: don't reject those applicants out of hand. Instead, take a closer look. New research shows that overqualified workers tend to perform better than other employees, and they don't quit any sooner. Furthermore, a simple managerial tactic, empowerment, can mitigate any dissatisfaction they may feel. The prejudice against too good employees is pervasive. Companies tend to prefer an applicant who is a perfect fit over someone who brings more intelligence, education, or experience than needed. On the surface, this bias makes sense. Studies have consistently shown that employees who consider themselves overqualified exhibit higher levels of discontent. For example, overqualification correlated well with job dissatisfaction in a 2008 study of 156 call center reps by Israeli researchers Saul Fine and Baruch Nevo. And unlike discrimination based on age or gender, declining to hire overqualified workers is perfectly legal, but even before the economic downturn, a surplus of overqualified candidates was a global problem, particularly in developing economies, where rising education levels are giving workers more skills than are needed to supply the growing service sectors. If managers can get beyond the conventional wisdom, the growing pool of too good applicants is a great opportunity. Baron Erdogan and Talia N. Bauer of Portland State University in Oregon found that overqualified workers' feelings of dissatisfaction can be dissipated by giving them autonomy in decision-making. At stores where employees didn't feel empowered, overeducated workers expressed greater dissatisfaction than their colleagues did and were more likely to state an intention to quit. But that difference vanished where self-reported autonomy was high. Computer scientist Shwetak Patel and his team are developing new sensing systems. The initial focus was really around energy and water monitoring. They built a new generation of smart sensors that monitor electronic interference on a home's power line or water pressure changes in the plumbing. Most of this technology has already found industrial applications, and Patel and his team turned their attention to adapting the technology for personal health monitoring. So how do we take this noise and make it into a signal? Interest was hard to us in the core of what we did for many years, and we're taking that work and applying it to other domains. They're looking to take advantage of all the functionality built in our smartphones. With the user's permission, this app can use the microphone built into most smartphones to listen to background noises, such as coughing, searching for patterns that suggest a trip to the doctor might be in order. We've constructed these models that try and understand how sound works, what its patterns are, and we give it a whole bunch of examples of different kinds of audio, things like people talking, things like people laughing, sneezing, and of course coughing. This app uses a phone's camera to check hemoglobin levels in blood by analyzing the color of capillary fluid through the skin. Generally, what happens is if you're anemic, your bloods may be a little less red, and we take advantage of that by putting your finger over a camera of a phone. The camera of the phone can actually see the coloration of the blood, and this test uses the camera to tell parents worried about jaundice in newborn infants. Now, jaundice is something that doctors who have seen tons of babies. He just can figure out on a very basic level of it. Is this baby, do they need to get treatment, or are they in a good condition? While the first-time parent has no idea necessarily what jaundice might look like, the researchers say the built-in sensors found in smartphones are already commonplace, but their applications and their implications for our health and well-being may be more far-reaching than we ever imagined.
Turner, not surprisingly, painted one of the earliest pictures of London's fog in the 1835 painting The Thames Above Waterloo Bridge. Turner, as a true-born Londoner, is advertising his familiarity with London's air problem by putting smoke and atmospheric pollution at its centre. And as you can see in here, the bridge is the central element, which is a theme that's later taken up by Monet. And it's partly obscured by the steam and smoke which rises from both sides of the river. Here we see a shot tower, I think you can just about see it, which was constructed in 1826. Do you know what shot towers are? They produce shot for guns, ammunition, and they were very smoky, one of the more smoky industries. But it's barely visible, as you can see, as are the various industries on the Lambeth side of the river. There's on this side, there's a steamship about to dock or preparing to leave. It's black smoke thrusting up to join the kind of swirling arc of smoke there. William Rodner sees this painting as a potent essay on the energy and complexity of modern polluted urbanism. Smoke, I think, here represents a flourishing economy which brings employment and food on tables, but also the dirt and pollution associated with its fumes. All seems to be tainted by a sulphurous yellow.
There's sugar in a lot of foods where you don't expect it. And of course, there's lots of sugar in donuts or ice cream or pastries or other things that are sweet, candy of course. But there are other places where you see it and you don't necessarily expect it. So as an example, peanut butter. Here's a list of ingredients from Skippy peanut butter, and you see that sugar is the second most common ingredient. Excuse me, you may know from reading food labels that these ingredients in any food label are listed in order of how much there is in the food itself. So sugar comes right after peanuts. Here's another example, beef stew. You wouldn't necessarily expect to find sugar in beef stew, but it's there. Now it's down the list of ingredients. It's actually toward the end. But if you look at the marketing of this and look at the can, it says there's fresh potatoes and carrots, but actually there's more sugar in this than there is carrots. And so you wouldn't eat something like beef stew and expect to find this to be the case.
What is going on, guys? My name is Bucky Roberts and welcome to your very first tutorial in biology. Now, in this video series, what I want to do is I want to talk to you guys about many different topics concerning biology. For example, I want to talk to you guys about DNA and genetics and cells and bacteria and life and a whole bunch of interesting stuff. But since this is the very first video, I think what we should do in this video is just stick with the very basics. And the first thing I want to do is talk to you guys about what is biology. So let's go ahead and answer that question. And the definition of biology is this: the study of life and living organisms. Alright, that makes sense up to a certain point, up until organisms, because you may have heard of organisms before, and you may have your own definition, but the scientific definition of an organism is a living thing. Well, that's easy. We know what living things are. I'm a living thing. Plants, grass is a living thing. My puppy, named Old Dan, cutest puppy ever, by the way, is a living thing. But whenever we talk about living things, believe it or not, things get kind of complicated, because then you have to ask yourself, what is life? Well, of course, if you ask your grandma or your best friend, or even if you ask a philosopher, what is life? Everyone is going to give you kind of a different definition of their outlook on life. However, whenever scientists and biologists were first deciding, you know what is life? That's the problem that they had. Everyone had their own separate definition of life itself. So what they needed to do before biology was even invented, which is of course the study of life, is scientists needed to agree on the definition of life.
As Joanne pointed out, only one country, tiny little Bhutan, wedged between China and India, has adopted the gross national happiness as the central index of government policy, and actually has had a good deal of success in education and in health and in economic growth and in environmental preservation, and they have a rather sophisticated way of measuring the effects of different policies on people's happiness. But they are the only country to go that far. But you're now beginning to get other countries interested enough to do kind of white paper policy analyses about whether happiness research, what effects would it have if we used it more for public policy. You're beginning to get countries like Australia, France, Great Britain that are considering publishing regular statistics on happiness. So it's beginning to become a subject of greater interest for policymakers and legislators in different advanced countries.
Welcome to today's lesson. We are continuing with our study of taxonomy. Taxonomy is how scientists classify organisms into different groups based on the characteristics that they share. So for instance, a good way to think about taxonomy is the U.S. Postal Service. If we want to send a letter to someone, we first start off by addressing it to the nation they're in. By default, we usually assume that's America, but it doesn't have to be. It could be England or Costa Rica or Spain. You put their nation or their kingdom. Then within that kingdom, you address it to a slightly more specific level, their state. So for instance, South Carolina would be the same as a phylum. Then within that state, you would address it to their city, and then to their street number, the street they live on. Then you would address it to, say, their apartment complex, and within that complex you'd address it by their last name to their family, and then finally their first name to the specific person you want to get it to. And in that way we're able to weed out all the 400 million people we don't want to send our letter to in America, and pinpoint the exact person we want the letter to reach. And in the same way, scientists use a taxonomy chart to pinpoint a living creature, an organism, and how it relates to everything else in the world.
So, what do we mean by well-being? Health, happiness, a sense of achievement and contentment, a state of mind and body where people can thrive. Well-being is not something that is purely limited to people who are facing extraordinary challenges in their lifestyle, health, or personal circumstances. Everybody here has a level of well-being. Music so often forms an intuitive part of our well-being management. Music to pick us up, music to calm us down, music to heal our sorrows. Our aim, through research, is to move from this level of intuitive application of music through to informed use in our communities, to take the next step in the understanding of the power of music in human life. Music already works for us on so many levels, whether it's soothing and teaching our infants, bringing people and communities together, adding spirit to our work and personal endeavors. But there is no reason to stop here.
A new study of fish called sticklebacks shows that shy individuals actually prefer to follow fish that are similarly timid. This is Scientific American's 60-Second Science. I'm Karen Hopkin. This'll just take a minute. Researchers had trios of sticklebacks with known personalities play follow the leader. The fish were placed in a tank that had some plastic plants at one end and some food hidden at the other. In some of the groups, a bold fish and a shy fish acted as leaders, while another shy fish followed. And in other groups, it was a bold fish that did the following. The researchers recorded whether the follower sallied forth more frequently with the fish that was behaviorally similar or the one that was different. What they found is that shy fish were more likely to emerge from under cover when an equally wary fellow was already out there. Bold follower fish did not seem to care as much which leader they followed. Of course, no matter which fish a stickleback chose to stick with, the bold fish did lead more joint expeditions over the course of the experiment than their more retiring friends. That's because the bold fish initiated more trips, regardless of who might be tailing them. The researchers write that when offered a choice of leaders, sticklebacks prefer to follow individuals whose personality matches their own. But bolder individuals may, nevertheless, be able to impose their leadership, even among shy followers, simply through greater effort. Thanks for the minute. For Scientific American's 60-Second Science, I'm Karen Hopkin.
But we can really thank the Great Exhibition of 1851 for giving us the world's premier taxi service. For it was going to this exhibition, this fabulous exhibition of inventions from all around the four corners of the empire, that the visitors were appalled, dismayed and vexed by their journeys to this exhibition, because the cabbies of the day in their horse-drawn carts were absolutely terrible, could not find their way to this exhibition. And so, at great public outcry, the London authorities set up the Public Carriage Office, which is an organisation that still exists, and you can take a short walk to Penton Street up the road. And this Public Carriage Office took on the responsibility of licensing all major taxi drivers in London. All taxi drivers from 1851 onwards had to pass what is now known as the London Knowledge, this phenomenal knowledge of London. What is the London Knowledge? It's the ability to remember the 25,000 streets, how they're all interconnected, and know all the main arterial roads in and out of London. Cabbies need to know all this, plus 1,000 points of specific interest, cafes, bars, public offices. They need to know them all as part of their training.
Now, the economists calculated, it's a back-of-the-envelope calculation, that removing all immigration controls would double the size of the world economy, and even a small relaxation of immigration controls would lead to disproportionately big gains. Now, for an ethical point of view, it's hard to argue against a policy that will do so much to help people that are much poorer than ourselves. The famous RAND study reckons that a typical immigrant who arrives in U.S. ends up with $20,000 a year. That's rough. It's not just the migrants themselves who gain, it's the countries they come from. Already, the migrants working for poor countries, working in rich countries, send home around $200 billion a year. Through formal channels and about twice as that through informal channels. And that compares to the $100 million that Western governments give in aid. These remittances are not wasted on weapons or siphoned off into Swiss bank accounts. They go straight into the pockets of local people. They pay for food, clean water, and medicines. They help kids in school, and they help start up new business. Sample answer: removing immigration control would double the world economy. This policy will do so much to help poor people. Immigrants end up with $20,000 a year from gains in countries they come from. They send home around $200 billion a year through formal channels, which are twice as that through informal channels. These remittances can help local people for living straightly.
I have said before that you can't have a civilization that doesn't have art. When we think about the great civilizations historically, all of them had great production of culture and art because a society has to be able to observe itself. And the sophistication of the great civilizations were their ability to look at themselves. And what allows a society to do that are the producers of art and culture. It would mirror back to the core of the society exactly what is being produced at that moment, how people are thinking of themselves, and how individuals are relating to the social structure at that time. Art is the vehicle through which we understand that. Were you to take away art, what would be that mirror? How would we see what we are about? How would we understand what was going on in Paris at the time of the Impressionists when people were learning to see in a completely different way? Cinematography, all of these things are just emerging, and here are people looking at the world in a very different way, which was considered so radical at the time.
So when we talk about the polar regions, just to clarify exactly what we mean, we have first of all the Arctic at the top of the Earth and the Antarctic at the bottom. So the Arctic was named after the Greek word for bear. Now surprisingly, it's not after the polar bears that live in the Arctic, but it's after the Little and Great Bear constellations that can be seen in the sky. Now the Greeks also hypothesized that there would be an anti-Arctic, which is how we get the name Antarctica, but of course it wasn't discovered until much later on. Now these regions are opposite in many ways other than just their names and their location on the globe. So if we look at the Arctic first of all, the Arctic is actually ocean surrounded by land. So we can see here, this is the UK down here, and this is kind of Russia, and then America and Canada around here. So there is a bit of land covered in ice in the Arctic, which is Greenland here, but mostly all this area here. Surprisingly, a lot of people don't realise that this isn't actually land. The North Pole isn't on land, it's just one big ocean.
In 1943, what became known as the Green Revolution began when Mexico, unable to feed its growing population, shouted for help. Within a few years, the Ford and Rockefeller Foundations founded the International Rice Research Institute in Asia, and by 1962, a new strain of rice called IR8 was feeding people all over the world. IR8 was the first really big modified crop to make a real impact on world hunger. In 1962, the technology did not yet exist to directly manipulate the genes of plants, and so IR8 was created by carefully crossing existing varieties, selecting the best from each generation, further modifying them, and finally finding the best. Here is the power of modified crops. IR8, with no fertilizer, straight out of the box, produced 5 times the yield of traditional rice varieties. In optimal conditions with nitrogen, it produced 10 times the yield of traditional varieties. By 1980, IR36 resisted pests and grew fast enough to allow 2 crops a year instead of just 1, doubling the yield. And by 1990, using more advanced genetic manipulation techniques, IR72 was outperforming even IR36. The Green Revolution saw worldwide crop yields explode from 1960 through 2000.
I want you to try and remember 2 things. First, I want you to try and remember learning how to ride a bike. Maybe you have a scar you received when you flipped over the handlebars. The next thing I want you to remember is how to ride a bike. The reason I asked you to recall both of these memories is that they belong to two different designated realms of memory. Memory is a fluid and dynamic system that is exceedingly complicated. To this end, psychologists have attempted to divide memory up to make it easier to study. There are two main categories. Explicit memory is a memory that can be intentionally and consciously recalled. This is your memory of riding a bike, and falling over the handlebars and skinning your knee. The other is implicit memory, which is an experiential or functional form of memory that cannot be consciously recalled. This is your memory of how to ride a bike or how to balance. These are often not tied to a visual memory, but are more like muscle memory. The examples of implicit memory include using language naturally, driving and reading, and answering multiple questions in the test, etc. will be natural. Let's look at explicit and implicit memory in a little more detail and see how age influences these. It is an experimental or functional form of memory. Explicit memory consists of a great deal of highly personal memories related to time, space, and people. It is totally different from implicit memory. Now, if we look at the examples of explicit memory, it includes remembering people's birthdays and answering multiple questions on the test.
The Earth's temperature is rising, and as it does, springtime phenomena, like the first bloom of flowers, are getting earlier and earlier. But rising temperatures aren't the only factor. Urban light pollution is also quickening the coming of spring.
So temperature and light are really contributing to a double whammy of making everything earlier.
Richard French Constant, an entomologist at the University of Exeter. He and his colleagues compiled 13 years of data from citizen scientists in the UK who tracked the first bud burst of 4 common trees. And it turns out light pollution from streetlights in cities and along roads pushed bud burst a full week earlier, way beyond what rising temperatures could achieve. This disruptive timing can ripple through the ecosystem.
The caterpillars that feed on trees are trying to match the hatching of their eggs to the timing of bud bursts, because the caterpillars want to feed on the juiciest and least chemically protected leaves. And it's not just the caterpillars, of course, that are important, but the knock-on effect is on nesting birds, which are also trying to hatch their chicks at the same time that there's the maximum number of caterpillars.
So earlier buds could ultimately affect the survival of birds and beyond. The findings are in the Proceedings of the Royal Society B. The world's becoming increasingly urbanized, and light pollution is growing, which French Constant says could trick trees into budding earlier and earlier. But smarter lighting, like LEDs that dial down certain wavelengths, could help.
Perhaps the exciting thing is that if we understand more about how light affects this bud burst, that we might be able to devise smarter sort of street lighting that has less red components and therefore less early bud burst.
Thus keeping springtime an actual springtime phenomenon.
So that creates tensions, and that's what I want to talk about, because I think it's important that we are, as a society, able to have an informed debate about how much privacy is enough but not too much, how much security is enough but not too much. Privacy is a human right. That's simply quoting the Universal Declaration. In the physical world, we've got all kinds of protections. This is evidence that we care about our privacy. We've got doors, we've got obscured glass, we've got locks. We wear clothes. We put up shutters. And technology continues to erode the privacy that exists in the real world, in the 3 spatial dimensions. Security cameras, automatic number plate recognition take away anonymity. Long lenses, paparazzi, take away distance and the privacy that used to create. And body scanners are increasingly being used to see through clothes, for example. this process isn't going to slow down, and the new quantum technologies are actually being able to do gravitational sensing, and that's advancing at a remarkable rate, and you can't shield gravity. So some of the new quantum technologies are able already to see through walls, and there are technologies also for seeing around corners now using scattered light from lasers. Technology continues to erode privacy.
All my research, and that I conducted with my 60-plus graduate students, was motivated by the need to learn so that we can teach. Of course, some inventions happened along the way, but I have always considered that the end result, I always considered these inventions to be byproducts of the learning process. The end product for me was always better understanding, or when one really succeeded, a unifying theory that can help us in teaching the subject. I have also looked at teaching as a vehicle to try new ideas or new ways of doing things on an intelligent group of learners. That is, as a vehicle for teaching research results. In my experience, this kind of teaching is the most stimulating and motivating to students. I have also uncovered many interesting research problems in the course of teaching a subject. It is this unity of research and teaching, their close connection, and the benefits garnered by exercising their interplay that to me characterizes the successful professor.
Today we're going to recount heroic tales of superhuman feats of strength, when in the face of disaster, some people are said to have summoned up incredible physical power to lift a car off of an accident victim, move giant rocks, or like Big John of song, single-handedly hold up a collapsing beam to let the other miners escape. Are such stories true? There are many anecdotes supporting the idea, but we're going to take a fact-based look at whether or not it truly is possible for an adrenaline-charged person to temporarily gain massive strength. In proper terminology, such a temporary boost of physical power would be called hysterical strength. The stories are almost always in the form of one person lifting a car off of another. In each of these cases, some aspect of leverage or buoyancy probably played some role in reducing the magnitude of the feat to something more believable. And even lifting many cars by several inches still leaves most of its weight supported by the suspension springs. But our purpose today is not to debunk any of these specific stories. The majority of them are anecdotal, and interestingly, not repeatable. In many cases, the person who summoned the super strength later tried it again only to find that they couldn't do it. Basically, what we have is a respectably large body of anecdotal evidence that suggests that in times of crisis, danger, or fear, some people have the ability to temporarily exercise superhuman strength.
During this time, my goals are going to be to talk about the phenomenon that we may share in part with other animals and our language, and that is emotion. And also talk about some new technology, brain imaging, functional magnetic imaging, and we try to answer some very old questions about how does motivation and emotion work. I'm going to put you with the scenario first, and some of you may be familiar with it. This was developed by Pavlov over a century ago. And in this scenario, the dog presented with the sound. The dog waits and then feeds food powder, and this happened repeatedly. Things starts to happen in the middle of the experiment there. Interesting things start to happen here. Pavlov's study was on the salivation of the dog. The salivation increases more time to paralyzes. But other things happen here too. You have a dog move around here more. All kinds of things are going on here. What we are trying to capture was the experiment going on to describe today what is going on in the brain to generate that state, which is called competitive state. But you can also think about state in terms of how the dog's feeling layer, how you are feeling about eating lunch today. Amory Lovins is an American consultant, experimental physicist, and he has been active at the nexus of energy, resources, economy, environment, development, and security in more than 50 countries for over 40 years. He pays attention on energy saving and how to use energy in a more efficient and sustainable way. He built a house with plenty of energy-saving concepts. He's an unusual character with a wide range of knowledge and a genius, but he is not a scientist. He has a consulting company and lives in a house that is built on a mountain. For 30 years, he used a lot of ways to save energy and solved problems with technologies that already existed and demonstrated them. Some people think he is so crazy. A female writer wrote a book about him, which is called Mr. Green.
Today we will discuss the relationship between the fault lines in the Earth's crust and an earthquake. This dislocation of the rock occurs from the Earth's surface 7 kilometers to several hundred kilometers vertically down to the crust. The earthquake's focus is called the epicenter, which is vertically beneath the interior of the Earth's crust, and the energy releases and transfers through epicenter. The faults are the fracture on the Earth's crust. The position of the epicenters can be identified by the faults map, looking down from the center of the Earth. It will result in seismic wave, which is decreased as it moved away from the epicenter. The first thing I want to argue is that former civilization is running into pretty profound crisis in its relationship to the rest of nature, which we do and what we have depended on for survival and for flourishing. And this is the most widely and well-recognized relation to climate change, CO2 emissions, greenhouse gas emissions. But I want to argue the certain dangers in the way that has been presented as the central question that we have to address. Because it's interlocked with a number of other crises, that is most notably as the crisis in the access to fresh water, crisis in access to food, biodiversity loss on a huge scale, and associated problems of human inequality, and not just in the common world, but actually in the kinds of environmental resources and pleasures that I can enjoy. So all those together have to be looked at as interconnected set of really deep, profound crises. According to the World Health Organization, 400 million people worldwide have no access to essential health care. That's a staggering number of people. Some of those services include things like basic sanitation and clean water, prenatal care, and vaccinations or immunizations for children. Many things contribute to this crisis. Sometimes people live too remotely to get timely care if emergency occurs. Even when living in a city, the patient-to-doctor ratio can be as high as 50,000 people to just one doctor, making it impossible for that doctor to meet the demands of health care in that area. These are valuable people made in the image of God who are physically suffering. Many of them go without a personal relationship with Christ. So we do this with a week of hands-on training consisting of a variety of topics like basic sanitation and hygiene, taking vital signs, wound care, and infection prevention, basic birth assisting, and emergency skills. Those who participate in training then have practical skills in supplies to care for others in the community in a way that glorifies God and opens a door for sharing the gospel in a new way.
I marveled at how often powerful feel powerless. But in the face of this sense of disempowerment, there's no decline in involvement in organisations which seek to share wealth and opportunities, which seek to protect one another's rights and work towards the common good. According to the UN, civil society groups have grown 40-fold since the turn of the last century. Last century. Internationally, the non-profit sector is worth $1 trillion. There are 700,000 not-for-profit organisations in Australia alone. 700,000. The UN recognises 37,000 specifically civil society organisations across the globe working in international relief and gives accreditation to many of them. This profound movement towards harnessing voices and resources from outside the realm of governments and officialdom reflects a growth in trust. The third sector, NGOs. Putnam, who discovered in the field of local government in Italy, the best predictor of governmental success was the strength and density of a region's civic associations.
Community service is an important component of education here at our university. We encourage all students to volunteer for at least one community activity before they graduate. A new community program called One-on-One helps elementary students who've fallen behind. You education majors might be especially interested in it because it offers the opportunity to do some teaching, that is, tutoring in math and English. You'd have to volunteer 2 hours a week for one semester. You can choose to help a child with math, English, or both. Half-hour lessons are fine, so you could do half-hour of each subject, 2 days a week. Professor Dodge will act as a mentor to these tutors. He'll be available to help you with the lesson plans or to offer suggestions for activities. He has office hours every Tuesday and Thursday afternoon. You can sign up for the program with him and begin the tutoring next week. I'm sure you'll enjoy this community service and you'll gain valuable experience at the same time. It looks good on your resume too, showing that you've had experience with children and that you care about your community. If you'd like to sign up or have any questions, stop by Professor Dodge's office this week.
The amount of money drug companies spend on TV ads has doubled in recent years, and it's no wonder. Studies show the commercials work. Consumers go to their doctors with a suggestion for a prescription drug they saw advertised on TV. Now, a study in the Annals of Family Medicine raises questions about the message these ads promote. NPR's Patty Naiman reports.
You are most likely to see drug ads during prime time, especially around the news. Researchers analyzed 38 ads aimed at people with conditions like hypertension, herpes, high cholesterol, depression, arthritis, and allergies. The drug industry says these ads arm consumers with information, but researchers found that though the information was technically accurate, the tone was misleading. UCLA psychologist Dominic Frosch headed the study.
What we would see in these ads is that before taking the prescription drug, the character's life was out of control. And the loss of control really extended beyond just the impact of the health condition.
For example, herpes patients were portrayed as being incapacitated for days, insomniacs utterly out of sync on the job, and depressed patients friendless and boring at parties.
When the character is then shown taking the drug, he then magically regains complete control of his life.
None of the ads, of course, mentioned lifestyle changes that could also help treat the condition. After all, it's mass marketing. But in this case, Frosch says, prescription medications are not like soap.
Determinant. Human behavior is affected by internal and external factors. At the end of the lecture, the speaker mentioned that psychologists are interested in explaining human behavior. Determinant is influenced by two factors, the personal factors, which are internal, and the environmental factors, which are external. The personal factors include people's belief on certain things and their individual thinking about it, while the environmental factors include temperature, air pressure, and the others thinking about them. In conclusion, one's determinant are affected by both himself and the environment. Straight salary sales compensation plans aren't very common, but they do have a place in some organizations. With this type of structure, you'd pay your salespeople a straight, albeit competitive salary, like all of your other employees and nothing else. No bonuses, no commissions, and few, if any, sales incentives. This type of compensation plan is most often used when the industry you operate within prohibits direct sales. When salespeople work as part of a small group or team and all contributions are equal, when your sales team is relatively small, or when your salespeople are expected to spend much of their time on other responsibilities other than selling. However, these plans don't tend to offer motivation to salespeople, as there are no incentives for them to work harder. Salary plus commission sales compensation plans are possibly the most common plans used today. They're structured in a way that salespeople receive a lower base salary along with commission pay that makes up the majority of the total compensation. Organizations use salary plus commission sales compensation plans when there are opportunities to support all salespeople on this structure and when there are proper metrics in place for tracking cells to ensure that the splits are fair and accurate. This type of plan is often the better choice as opposed to straight salary because it offers motivation to increased productivity and to achieve goals. It also offers more stability. Sales people will still get some type of pay even if they're in training. When sales are low during certain months or if market conditions get volatile. However, it can be more complex to administer. Commission-only sales compensation plans are exactly what they sound like. You pay your salespeople for the sales they bring in and nothing else. There is no guarantee of income. These types of plans are easier to administer than salary plus commission and provide better value for your money, paid as they are based solely on sales achieved. They also tend to attract fewer candidates, but do attract the most top-performing and hardest-working sales professionals who know they can make a good income because they know how to sell. On the other hand, though, they can create aggression within your sales team and low-income security, which can lead to high turnover rate and sales rep burnout from stress. A non-governmental organization, NGO, is an organization that is neither a part of a government nor a conventional for-profit business. Usually set up by ordinary citizens, NGOs may be funded by governments, foundations, businesses, or private persons. Some avoid formal funding altogether and are run primarily by volunteers. NGOs are highly diverse groups of organizations engaged in a wide range of activities and take different forms in different parts of the world. Some may have charitable status, while others may be registered for tax exemption based on recognition of social purposes. Others may be fronts for political, religious, or other interests. The number of NGOs in the United States is estimated at 1.5 million. Russia has 277,000 NGOs. India is estimated to have had around 2 million NGOs in 2009, just over one NGO per 600 Indians. And many times the number of primary schools and primary health centers in India. NGOs are difficult to define, and the term NGO is rarely used consistently. As a result, there are many different classifications in use. The most common focus is on orientation and level of operation.
What I've decided to provide is the steps I take when analyzing my own questionnaires. However, before I begin, it would be useful to remind you of a few terms we use when taking questionnaires. Questions can be divided into 3 types. This is sometimes called level measurement. Firstly, we have a category type questions, which are also known as nominal questions. These are when participants select from a list of categories for their response, such as male or female, or they may include ethnic origin. Secondly, we have ordinal type questions. These are similar to category questions, but instead of the categories being independent, there is some sort of order between them. If we ask people to indicate their age in categories, this is an ordinal type question. Thirdly, we have continuous questions. These are any questions that can be answered by a number. It could be an open-ended question asking participants to tell you how many times they attended lectures or how often they used a VLE, or it could involve asking them to rate the importance of intensity of some experience.
We can ask 2 fundamental questions about animal behaviour. They're referred to as proximate and ultimate. Proximate questions are those concerned with the mechanisms that bring about behaviour. Ultimate questions are those concerned with the evolution of behaviour. We can divide the proximate and ultimate questions into 2 sub-questions. For proximate, how does the behaviour develop? And secondly, what causes the behaviour? For ultimate, we can ask, how did the behaviour evolve? And secondly, what is the adaptive significance of the behaviour? What's its purpose? Together, these comprise what are called Tinbergen's 4 questions about animal behaviour. Nico Tinbergen was one of the founding fathers of the study of animal behaviour. These questions represent the different ways of studying animal behaviour, and understanding the difference between those 4 questions are fundamental to understanding behaviour and indeed the whole of biology. How do we study animal behaviour? Well, that depends on the type of question we're hoping to answer.
He said, innovation equals invention, and let me just stop here. Innovation equals invention. Often people mistake these two things for the same thing. Innovation equals invention. They are not. Innovation is something that generates value for the world. It makes something faster, better, cheaper. It gives someone some great satisfaction. An invention is an idea, a technology, a patent. In and of itself, it does not generate value. So these two are not the same thing. And sometimes you see them interchanged, and that's not correct. So innovation equals invention times commercialization. So, and when we look at this equation of innovation, something of value, it requires a new idea, and then it requires someone or some organization that is going to commercialize that idea and to make it of value to the world.
Vitamin D refers to a group of fat-soluble corticosteroids responsible for increasing intestinal absorption of calcium, iron, magnesium, phosphate, and zinc. In humans, the most important compounds in this group are vitamin D3, also known as chlorocalciferol, and vitamin D2, ergocalciferol. Calciferol and ergocalciferol can be ingested from the diet and from supplements. Very few foods contain vitamin D. Synthesis of vitamin D in the skin is the major natural source of the vitamin. Dermal synthesis of vitamin D from cholesterol is dependent on sun exposure, specifically UVB radiation. Vitamin D from the diet of dermal synthesis from sunlight is biologically inactive. Activation requires enzymatic conversion, hydroxylation, and in the liver and kidney. Evidence indicates that synthesis of vitamin D from sun exposure is regulated by a negative feedback loop that prevents toxicity. But because of uncertainty about the cancer risk from sunlight, no recommendations are issued by the Institute of Medicine for the amount of sun exposure required to meet vitamin D requirements. Accordingly, the dietary reference intake for vitamin D assumes no synthesis occurs, and all of the person's vitamin D is from food intake, although that will rarely occur in practice. As vitamin D is synthesized in adequate amounts by most mammals exposed to sunlight, it is not strictly a vitamin and may be considered a hormone, as it is synthesis and activity occur in different locations. Vitamin D has a significant role in calcium homeostasis and metabolism. Its discovery was due to effort to find the dietary substance lacking in rickets.
Protons are finally transferred to the LHC both in a clockwise and an anti-clockwise direction, where they are accelerated for 20 minutes to 6.5 TeV. Beams circulate for many hours inside the LHC beam pipes under normal operating conditions. For each collision, the physicist's goal is to count, track and characterize all the different particles. The charge of the particle, for instance, is obvious since particles with positive electric charge bend one way and those with negative charge bend the opposite way. Also, the momentum of the particle can be determined. Large Hadron Collider (LHC) is the world's largest particle accelerator, lies in a tunnel. The LHC is a ring roughly 28 kilometers around that accelerates protons almost to the speed of light before colliding them head-on. Protons are particles found in the atomic nucleus, roughly 1,000 millionth of a meter in size. The LHC starts with a bottle of hydrogen gas, which is sent through an electric field to strip away the electrons, leaving just the protons. Electric and magnetic fields are the key to a particle accelerator.
Flipping a coin may not be the fairest way to settle disputes. About a decade ago, statistician Percy Diaconis started to wonder if the outcome of a coin flip really is just a matter of chance. He had Harvard University engineers build him a mechanical coin flipper. Diaconis, now at Stanford University, found that if a coin is launched exactly the same way, it lands exactly the same way. The randomness in a coin toss, it appears, is introduced by sloppy humans. Each human-generated flip has a different height and a different speed, and is caught at a different angle, giving different outcomes. But using high-speed cameras and equations, Diaconis and colleagues have now found that even though humans are largely unpredictable, coin flippers, there is still a bias built in. If a coin starts out heads, it ends up heads when caught more often than it does tails. NPR's David Kestenbaum reports.
Honeybees do a waggle dance to direct other bees to sources of nectar. But dancing bees like this one can be halted by a headbutt from another bee. Now researchers have found that this headbutt is actually a warning signal. A feeding station was set up in the lab to mimic a source of nectar. Then foraging bees were introduced to dangers at the station, such as competition from rival colonies. When foragers returned to the hive, they stopped bees dancing. Scientists think the behavior warns dancers of a dangerous source of nectar.
I'm just going to take on where Stafford left off, and the hormone I want to talk to you about is called melatonin, and it's synthesized in the pineal gland, which is a very small, it's the size of a pea in your brain. Descartes called it the seat of the soul, and it is where melatonin is made. Is this working? And it has a rhythm as well. And in a sense, it's the opposite of cortisol. It peaks at night. We call it the darkness hormone. In every species that we've studied, melatonin occurs at night. And it's a hormone that prepares you for the things that your species does at night. So, of course, in humans, we sleep. But animals like rodents, they're awake. So it's a hormone that is related to darkness behavior.
The shuttle was designed to be a space truck. It's a multi-purpose vehicle. We've done a tremendous number of different things with it. It's the most versatile space vehicle that has ever been built. We've used it to launch satellites. We've used it to repair satellites in orbit and put them back into orbit. We've used it to capture satellites and bring them back to Earth for repair. We've outfitted it with the Space Lab built by our European partners and used it before the era of the space station to do scientific research. We used it as part of our partnership with the Russians, which is still continuing, first as part of the Mir space station, where we actually prolonged the useful life of Mir by several years through logistical supply visits with the shuttle. And now, of course, we're using it to build the new International Space Station, which is a huge international partnership.
Thermodynamics is simply defined as the branch of physics that deals with the conversion of different forms of energy, and the relations between heat and various energy forms such as mechanical, electrical or chemical energy. Kinetics deals with the actions of forces that cause various motions, also known as dynamics, and it is concerned with the rate of reactions. Temperature is the average kinetic energy within a given object. Thermal energy is defined as the total of all kinetic energies within a given system. It is important to remember that heat is caused by flow of thermal energy due to differences in temperature. Heat flows from object at higher temperature to object at lower temperature, transferred through conduction, convection, radiation. Additionally, thermal energy always flows from warmer areas to cooler areas. Energy occurs in many forms, including chemical energy, thermal energy, electromagnetic radiation, gravitational energy, electric energy, elastic energy, nuclear energy, and rest energy. These can be categorized in two main classes, potential energy and kinetic energy. Kinetic energy is the movement energy of an object. Kinetic energy can be transferred between objects and transformed into other kinds of energy. Kinetic energy may be best understood by examples that demonstrate how it is transformed to and from other forms of energy. For example, a cyclist uses chemical energy provided by food to accelerate a bicycle to a chosen speed. On a level surface, this speed can be maintained without further work, except to overcome air resistance and friction. The chemical energy has been converted into kinetic energy, the energy of motion, but the process is not completely efficient and produces heat within the cyclist. It is wrong, however, to exaggerate the similarity between language and other cognitive skills, because language stands apart in several ways. For one thing, the use of language is universal. All normally developing children learn to speak at least one language, and many learn more than one. By contrast, not everyone becomes proficient at complex mathematical reasoning, few people learn to paint well, and many people cannot carry a tune. Because everyone is capable of learning to speak and understand language, it may seem to be simple. But just the opposite is true. Language is one of the most complex of all human cognitive abilities. The Melk is not typical of all monasteries for many reasons. Firstly, it is very grand, which most especially later foundations aren't. Secondly, it was founded in the countryside, whereas in 17th and 18th centuries, a good proportion of foundations were made in towns. Thirdly, it still owns substantial amount of land, because fourthly it lies in the Austrian Republic, the only European country where grand old monasteries have been in continuous existence, since they were founded 900–1000, even in one case 1200 years ago.
What we're going to discuss today is how the Port of London was discovered and what we discovered about it. Now, if you look at the historical records of Roman London, there's only about 14 actual references to London in antiquity, i.e. contemporary references, and of those, only one is in the 1st century. There are none at all in the 2nd or 3rd century. There's only one in the late 3rd century, and there's 4 in the 4th century. So if you're a historian trying to write a history of Roman London, it's very difficult. You don't really have much data. You're going to depend on the archaeological evidence, the material evidence of the port and indeed the town to have any understanding of what happened then. And so what we're looking at here is, how did we discover about the Port of London? There is no historical documentations, no customs books, no tariffs, no idea of the taxes. We have to understand the port entirely from the archaeological evidence. So that's what we're going to do today. So if we move on to the next slide. I love live streaming, so thank you very much.
The comics I show you with lots of people chatting around in a room is a form of description. We use different kinds of methods to describe a situation. Sometimes we have to use visual description, particularly when we do not witness the scenario. I was born during the Second World War, and my hometown is X. For example, when I asked my mother about the war, I always ask her, "You have mentioned this or that when you talked to me when you asked her about the shelter. I asked her what the shelter looks like, and when did you go to the shelter?" From her response, I could get more visual evidence as I can to write my book.
In the solar system, many planets have rings. Saturn's rings are the most spectacular planetary ring. Consisting of countless particles whose diameters range from microns to meters, these rings orbit the Saturn. In 1610, Galileo was the first man who spotted Saturn's rings. With his 20-power telescope, Galileo might have mistaken Saturn's gaseous ring to surmise that the Saturn system was formed of one planet with 2 moons as satellites. In 1675, Giovanni Cassini determined that Saturn's ring was actually composed of subrings with gaps among them. So the number of Saturn's rings are more than 10. Other planets like Venus, Jupiter, Neptune, and Uranus also have rings, but not as many as Saturn has. Finally, scientists have dedicated themselves to study the formation of Saturn rings and claim that these rings are formed by gravitational fields. To someone first encountering the works of William Shakespeare, the language may seem strange, but there is a secret to appreciating it. Although he was famous for his plays, Shakespeare was first and foremost a poet. One of the most important things Shakespeare's language is his use of stress. Not that kind of stress, but the way we emphasize certain syllables and words more than others. We're so used to doing this that we may not even notice it at first. But if you say the word slowly, you can easily identify them. Poets are very aware of these stresses, having long experimented with the number and order of stressed and unstressed syllables and combined them in different ways to create rhythm in their poems. Like songwriters, poets often express their ideas through a recognizable repetition of these rhythms or poetic meter. Shakespeare's favorite meter in particular was the iambic pentameter, where each line of force is made up of 5 two-syllable items for a total of 10 syllables, and it's used for many of Shakespeare's most famous sonnets. Why did Shakespeare choose iambic pentameter for these moments? It's been said that iambic pentameter was easy for actors to memorize and for the audience to understand because it's naturally suited to the English language. But there might be another reason. Shakespeare's most poetic lines don't just talk about matters of the heart, they follow its rhythm.
And thanks for this opportunity to speak about Australia's engagement with Asia from the perspective of trade, and in particular to say a few words about what Austrade is doing in this space. I'm particularly pleased to be addressing trade and investment, not just, of course, because these two things are inextricably linked, but also, of course, because Austrade reports to Australia's first ever Minister for Trade and Investment. Asia's importance to Australia's economy is growing by the day. It is one of the most important factors to consider when assessing the international conditions for our national prosperity. Asian demand for our exports has helped Australia manage the global financial crisis better than most other developed economies, in fact probably better than all other developed economies. And investment from Asia has added to the productive capacity of the economy and to overall productivity. In 2013, 7 of our top 10 export markets were in Asia and represented 65% of our total exports. Asian markets and Australia's geographic proximity are critical, not just for our trade ties and our capacity to access important global supply chains, but also to the level of foreign investment in Australia. FDI has grown markedly in Australia over the past decade. In fact, it has more than doubled from about $292 billion to $630 billion in 2013.
We're thinking about this and we're trying to say, all right, well, let's file a patent on this clicker. If I were to go to the patent office and say, all right, I want a patent on a clicker, period. The patent office would just laugh. You know, the clickers have been around for a while, presentation clickers have been around for a while, and so there'd be a 0% chance that we would actually get that. If we were to somehow convince the patent office that we should be able to get a patent on a clicker, period, it would, however, be incredibly valuable. Every single clicker that was made after this point would infringe, and when it infringes, maybe we take $1 or $2 each. That would add up to be a decent amount of money. On the other end of the spectrum, let's go to the million-word version. I go to the patent office and I say, I want a patent on this exact thing. And those 1,000,000 words describe every single radius, every single material, every single thing about this. And the patent office says, yeah, we've never seen that before, go ahead and take it. Almost 100% chance of getting that patent. But the value of that patent would be close to zero.
Sometimes it's the little things that can make big things happen. Fleas and the plague, atoms and nuclear bombs, diminutive leaders in world history. Soot is one of these little things. Soot, also known as black carbon, is released when you burn dung, coal, diesel fuel, and wood. From LA to Mumbai, soot causes respiratory illnesses like lung cancer and asthma, and contributes to 1.6 million premature deaths every year, mostly among the poor. And it gets worse. Atmospheric currents carry soot thousands of miles from where it is produced to the Himalayas and the Arctic. Black carbon, being black, absorbs sunlight, so even a little soot on snow makes it melt faster. And when snow melts, global sea levels rise, threatening our freshwater, indigenous communities, and polar bears who hunt on the Arctic ice. Climate change has been a big thing for a while, and carbon dioxide has been its main cause. Scientists estimate that soot causes 25% of human-caused global warming. It's the second leading cause of Arctic warming after carbon dioxide. Let's not underestimate the impact of this tiny particle. But there's good news. Reducing black carbon may be the fastest way to slow global warming and buy time for the Arctic. Yes, even more so than changing a light bulb. And since black carbon only stays in the atmosphere for a couple of weeks, reducing it would produce results immediately. Of course, reducing soot alone won't solve global warming, but solving our soot problem now will help buy time for the Arctic and allow us to deal with the bigger problem of carbon dioxide. We have the cleaner industries, cook stoves, and diesel. Now we have to use them. In developed nations, we've significantly reduced our black carbon, but we still have much more to do. We need to tighten our standards at home and invest in cleaner technologies in developing nations. In a world going on 7 billion people, you might feel rather little yourself. But if you urge the US government and the European Union to take the lead on black carbon reduction, you can make a big difference. Go to stopsoot.org and help stop these little things from causing big trouble.
I'm a dietitian and I work in clinical weight loss research. Accurately estimating portion size is critical in research or real-world settings. For example, if you're trying to watch your weight and you're out to dinner and you're presented with a bowl of food, there's no really good way to actually estimate how much you're eating unless you're going to whip some scales out of your bag. So we wanted to find a more objective way for people to quantify what they're eating when they're out and about. I came up with a more hands-on approach. We got people to measure the dimensions of the food using the width of their fingers, and remembering back to primary school maths, we used the geometric volume formulas to estimate the weight of the food. To show you how this works, I've ordered a piece of lasagna, and that's my box, a glass of wine, and that's my cylinder, and I'm feeling pretty healthy, so I ordered some watermelon for dessert, and that's my wedge. So this lasagna is 7 by 5 by 4 fingers. In the future, I see this method being incorporated into smartphone applications. So you put your finger widths in, along with your height and your weight, and the app will do all of the calculations for you. And then you've got a more accurate way to estimate the portion size.
With over 40 years unrivaled experience and a worldwide reputation, BSI leads the way in testing and certification of fire safety products. Based in our dedicated labs in Hemel Hempstead, our team provides BSI kite mark and CE testing and certification for a broad range of products including fire extinguishers, hoses, alarm panels and heat and smoke detectors. We help clients to gain access into the European market by ensuring that products meet all the CE mark requirements. And we're familiar with the market access regulations of most countries across the world, enabling customers to enter markets globally. The BSI kite mark is categorised as a British super brand and acknowledged the world over as a symbol of trust, integrity and quality. It provides the reassurance that vital product safety and performance requirements have been met. Our team subjects each product to a rigorous set of tests, along with robust production control audits, designed specifically to ensure that they perform to required standards of safety and quality. We test for compatibility of fire detection and fire alarm system components to ensure that they're compatible and connectable. This service meets the growing requirement of European regulatory authorities to meet national installation guidelines. We also perform tests on individual detection components. Fire suppression products, such as fire extinguishers, are subjected to rigorous tests designed to ensure that they're effective, safe, and capable of performing in the environments and conditions in which they're stored and used. The symbols for BSI Kite Mark and CE certification represent quality, safety, and trust. For specifiers, they demonstrate a commitment to best practice procurement, and for the public, they provide the reassurance that fire safety products are effective and reliable.
Today we are going to talk about wave propagation. The speed of sound in 20 degrees Celsius is 343 meters per second, but one of light in vacuum is 3 times 10 to the 8th power meters per second. The speed of sound in 20 degrees Celsius is 343 meters per second, and the speed of light in a vacuum is 300 million meters per second. Why do we always see the lightning before we hear the thunder? It's because the speed of light travels much, much faster than sound. Another example can be found in a basketball game when you watch in a stadium. When you see a player score a basket, you find that the cheerful audience from across the court rise at the same time as you do, but their whoops arrive at your ears a little bit later. That's also because of the difference between the speed of sound and light. In India, a lot of people are working as community service workers. Quarterly meetings are held in order to provide training and consultation to them, and thus they can understand how to prevent diseases from spreading throughout the communities, such as HIV, which is difficult to be controlled. Such precaution knowledge is taught by professionals from large hospitals and organizations. But in some cities, large consultation is not suitable because it is hard for target groups to meet who live in remote areas. To deliver training to them, professional teams have to go across rivers.
Our civilization, which subsumes most of its predecessors, is a great ship steaming at speed into the future. It travels faster, further, and more laden than any before. We may not be able to foresee every reef and hazard, but by reading her compass bearing and headway, by understanding her design, her safety record, and the abilities of her crew, we can, I think, plot a wise course between the narrows and bergs looming ahead. And I believe we must do this without delay, because there are too many shipwrecks behind us. The vessel we are now aboard is not merely the biggest of all time, it's also the only one left. The future of everything we've accomplished since our intelligence evolved will depend on the wisdom of our actions over the next few years. Like all creatures, humans have made their way in the world so far by trial and error. Unlike other creatures, we have a presence so colossal that error is a luxury we can no longer afford. The world has grown too small to forgive us any big mistakes.
Deliberate practice takes time, and people also need to find and solve problems and mistakes during it. To be a high-performing solo musician for the violin, you also have to spend several dozen hundreds of hours in solitary practice. When it comes to other things, for example, studying geometry, it is still the case. During practice, you should identify your weakness, focus on it, and carry out further deliberate practice to demonstrate how important deliberate practice is. Even for talents, they generally need to spend 10 years to achieve the high international level of recognition. So there is no need for average people to be ashamed to practice. Over the past 5 years, the wage growth is about 5%, which is very weak. Meanwhile, consumption has grown about 15%, which seems decent. However, housing debt has increased by about 40%, which is unusual, but can be understandable after the wage and consumption increase. The increase in wages is far from sufficient to cover the increase in consumption. The increase in consumption is not because of the increase in income, but because people are borrowing more money to buy homes. Although people's wages increase, most of the money will go against paying household debt, because people spend a lot of money at home. Morton Prince was an American physician and physiologist. His book, Dissociation of a Personality, was the bestseller at that time. It tells a story of Miss Christine Beauchamp, who was suffering from MPD, multiple personality disorder. Miss Christine Beauchamp has several types of personalities, namely B1, B2, and B3. There was hidden memory in these 3 personalities, with hallucination among them. Miss Beauchamp was B2. B2 knows about B1. B3 knows about B1 and B2. But B1 knows nothing about B2 or B3. The strongest personality accounts for most of the time, and it will take over the others and become the main personality at the end. This case and theory gives great help to crime investigation. The biotech engineering has undergone 3 phases. In the first phase, people designed and made some simple machines, which aim to help people understand ourselves. And first group of people that realized we could learn from ourselves were engineers. And then, based on the studies, people began to make complicated devices in order to cure wounds, like the practice of suture, and to study physiology. This is the second phase. Later, since we went into the third phase, more complicated machines have been developed, like ECG, electrocardiography, able to have an insight of your internal body without intruding it, which can show the human brain's functions. X-ray is a good example. In an X-ray picture, you can see the bright area is the heart with some vessels around it, and the dark area is the lungs. These devices benefit humans greatly in solving health problems, such as diseases. Due to globalization effect, it is hard for people to hold a positive attitude towards Latin America's economy. Globalization had been widely believed to benefit people globally, including Latin American countries. But people are disappointed about the actual economic growth in that continent. Over the 20 years before globalization, the economy in Latin America developed by 80%. People thought taking part in globalization would achieve a higher economic growth rate. But in fact, the growth rate had dropped to 10% after economic reforms related with globalization happened in Latin America. Accordingly, the poverty rate has increased, and the criterion of poverty is earning no more than $2 per day. Thus, Latin America's economy has been unsustainable. People are asking why the economic development has been slower than that before reforms. So, globalization is not a perfect economic structure, which possibly has a negative effect.
After the recession era, Europe confronted a change in economy structures in Europe. After Industrial Revolution around the 19th century, the machinery was widely used in the manufacturing, so the production in factories increased. As a result, circulation of goods became faster, and this led to more accumulation of social wealth. Because of this, the population of middle class expanded, and this resulted in the additional accumulation of wealth. This research that conducted by pioneering scientists examined the extent and patterns of structural changes that have occurred in European economies during the recent crisis, using some stylized facts on changing output and employment structures at a detailed sectoral level. Focusing mainly on the new EU member states, we compared the performance of various European countries by looking at the differentiated impact of the recent crisis on structural shifts in their economy. We start with stylized facts related to output and employment structures at broader sectorial NACE2 level and attempt to find out whether there have been a structural convergence or divergence of the new EU member states, NMS, compared to the more advanced old EU countries, OMS, during the crisis. Finally, we provide also some policy conclusions related to the future role of the NMS in the economy of an integrated Europe, especially in view of post-crisis growth challenges. The financial crisis of 2008 to 2011 adversely affected the manufacturing industry more than services, particularly in terms of employment, and accelerated structural changes in favor of the services sector. The latter tendency was more pronounced in the NMS, though even here country, specific differences were remarkable. The importance of industry in this group of countries remains strong. There has been no EU-wide uniform pattern of structural change. The formulation of industrial policy at the EU level, even reaching the 20% target of industry's share in GDP, is challenging and hardly attainable.
We normally see blogging as a two-way interaction in which the blogger or author creates the content and the readers interact with or challenge the author. But the case will be much more difficult when it comes to governments, such as the White House, because people will become coarser and ruder online towards their governments, especially in the comment areas. Thus, governments' blogs may go wild and chaotic. And then governments will have to administrate the comments. Once the government starts to impose harsh administration on comment areas, citizens may find the government manipulating what should be said and what should be shown, which contradicts the original intention.
I think with our linguistic training, we are also get all this invisible training to be authorities, to be the people who know. It is part of that process that you come out as a world authority on your chosen subject. But when we move into working with communities, we have to recognize that communities have to be the authority in their language. Actually, a woman in the class I'm teaching at Sydney at the moment, a career woman, expressed this very nicely. Although she was talking about something else, she was distinguishing expertise from authority. And certain linguists, because of our training, we have expertise in certain very narrow areas of language, but we don't have the authority over what to do with that knowledge or what to do with our knowledge that the community produces. I guess for me, the bottom line is languages are lost because of the dominance of one people over another. That's not rocket science. That's not hard to work out. But then what that means is in working with language revival, we continue to hold the authority. We actually haven't done anything towards undoing how languages are lost in the first place. So in a sense, the languages are still lost if the authority is still lost.
Let's say if I'm asking which source you often use to get information, newspaper, radio, TV, and the survey shows 62% of the people chose internet. You might be thinking I am going to say how important the internet is, or how quickly it has changed the world for a few years. But what if I tell you this survey is conducted on the website globeandmail.com? Our answer will be different because the people who did this survey on a website must be frequent users of internet. This sample is a biased sample, so we have to pay attention to how a survey is conducted.
Absolutely. There's a lot of interest in what forms those clouds. Why are those clouds there? Why do they stick around? At the center of every cloud drop is a particle. You can't grow a cloud drop without having a particle there for the water to condense on. The key questions that people have not directly addressed until very recently is what actually forms those clouds. And so the ones that you're looking at over the ocean, it turns out sea salt is a very effective nucleator for forming clouds. So there's a really good chance that those are loaded with sea salt. But as you go inland, you start to have pollution come from all different kinds of sources. And so different sources form clouds more effectively than others. And we're trying to unravel which sources are actually contributing to the clouds. The clouds are incredibly important players in climate change, in that they reflect the light back to space.
and so they're keeping things much, much cooler than they would be if they weren't there. They also play a huge role in regional weather. So we're actually starting to see shifts where having more pollution input into the clouds is affecting weather patterns. And in particular, it's actually reducing the amount of precipitation. So we're starting to see drought in areas with super high levels of air pollution. Science let us know what is going on. Underwater remote detector, which is called Antares, is a kind of camera installed underwater in cages for fish monitoring in the industry of marine aquaculture. It is an advanced system of remote technology by which researchers can remotely monitor fish on their computers in their universities. The camera can detect surrounding environments as well as fish. This helps people find out what they eat, what they don't eat, and how much they do eat. Thus, people can stop feeding them if necessary in some situation to save time and labor. Well, there's a number of ways to think about what dimensions are. I hope we all know where 3 dimensions are, which you can say are left, right, forward, backward, up, down. And if you think about it, 3, we say there are 3 dimensions of space. And sometimes we need 3 coordinates to locate some objects in space. So you can say longitude, latitude, and altitude. So if there were more dimensions, you would need more coordinates. Now, of course, for whatever reason, we are not physiologically designed to observe those dimensions, but that doesn't mean they don't exist. One way of thinking about it is, maybe the best way of thinking about it is the way that someone named Edwin Abbott did in the late 19th century in a book called Flatland. And he said, suppose there were 2-dimensional creatures living in a 2-dimensional universe. They would have the same trouble conceptualizing 3 dimensions that we have when we try to conceptualize more than 3, such as 4. And so, he asked questions like, what would observers in this 2-dimensional universe see, say, if a 3-dimensional object like a sphere passed through the universe? And what this flatland universe would see would be a series of disks that grow in size and then decreased in size. In the same way that we can certainly think about a 2-dimensional world inside a 3-dimensional world, it could be that we observe 3 dimensions, but really there are more. And if a hypersphere, say a 4-dimensional sphere, passed through our universe, we could see a series of spheres that grew in size and then decreased in size. The fact that we don't observe those extra dimensions doesn't mean they don't exist, and they are hard to conceptualize. They certainly are hard to visualize, but we can think about them mathematically and conceptually without too much trouble. Can we never get to absolute zero? What a wonderful question. I wish I had a wonderful answer to go with it. Here's the problem. There is actually a law of physics called the third law of thermodynamics that says you cannot get to the absolutely zero. We don't really know it's true, but we are pretty sure it is for the following reason. Every time you think of some way of cooling something down a little bit, it means you try to get energy out of that thing and make the temperature lower. Well, if you can get energy out, usually there is a way that the energy can go in as well. And that always means there is a competition between taking the energy out and putting the energy in. Now, you can try to make it so you are favoring getting energy out, but you can't completely stop the energy from going in, and that means you might be able to get colder and colder, but you won't be able to get all the way to absolute zero. Could we go back to my PowerPoint? Because I think that one of these slides will illustrate that point a little bit better. Yes, here, remember the logarithmic thermometer? There is no zero on this logarithmic thermometer, it just keeps going down. You make it a fact of 10 colder, you're not a zero. You make it a fact of 10 colder, you're still not a zero. You make it a fact of 10 colder, you're still not a zero. So you start 1,000,000 of a degree, now you are 10 millions of a degree, now you are 100 millions of a degree. Now you are billions of a degree. You never get to zero that way. You get closer and closer, but you never get to zero. So that's why we cannot get to absolute zero. Why is it difficult to make a robot like a human being? Why can't robots finish the work easily like human beings? For some tasks, it is easy and simple for humans to complete, but it is very difficult to ask a robot to do what we want because humans and robots have different recognition functions. For example, Considering the insights, it is hard for robots to recognize colors because they do not have sensory mechanisms. Artificial intelligence scientists have to devise a sensor that is implanted to robots to enable them to recognize different colors. The sensor has a camera on it to capture pixels, and then will translate the pixels into an image, which is not as easy as expected. This process is very complex. The translation of every pixel to accurate things could be difficult, especially color differentiation, which needs complicated sensors to fulfill. So the improvement of the sensor is necessary. In conclusion, there is no comparison between humans and robots. Minor languages are disappearing at a rate that has never been seen before in history. The main reason for the minor language extinction is globalization and urbanization. People in rural areas tend to move to urban areas. The stress of life in big cities makes people who have moved there from the countryside have to be bilingual, to learn to speak the language used by the majority there and only speak their own minor languages as an auxiliary one. So big cities are not good places for minor languages to survive. And mainstream or dominant languages such as English have been taking place of many small languages there. Thus, only people who stay in remote territories preserve their minor languages very well. For example, those who live in isolated islands. Today, such a linguistic change may cause an ethnic concern, and surrounding culture and tradition more and more controversy has risen.
But Aristotle says the reason we need rhetoric is we have to be able to use it. To use rhetoric influence the ramble. We try to get them to understand truth. Truth is suggest, is different than rhetoric. Rhetoric is the dressing, is the body, right? Truth is the spirit, is the soul, is abstract. It doesn't have a body. It's not particular. If you want to get somebody to the truth, you might have to use some kind of tricks, right? Because most of people are not sound and can see the truth. That's what we think. Most people are rambles, really. Only the educated, be erudite, are actually capable of seeing the truth. If you want to get the general mass there, you may have to do a little bit. So Aristotle, that is rhetoric. Rhetoric is something that is used to influence people, right? And it's kind of mentally promised a logic. Happiness comes from frequency and quality of social relation. The higher the frequency is, the more happiness relations with friends and family and others produce. It is not sure why social relation is correlated with happiness, but there's evidence that when people feel more satisfied with their social relations, they will feel happier. In turn, when people feel happier, they will get more satisfied with social relations. Happy people tend to be more social with friends and have more interaction between family. Some people wonder if their social activities make them happier, or their happy personalities drive them to be more social more with their friends and family.
Language is a human essence that defines human characters. Language disorder is children's disability to produce speech. 10% of children have language disability in the U.S. People cannot take it for granted and should this problem seriously. Children's language is different from that of adults, so it should be dealt with separately. Not being able to generate sentences is a physiological issue because it involves a children's psychology. In adults, it is a logical issue. To solve this problem, we need to ask questions about language itself first. We should know what language is, how language is learned, and how children can speak different sentences by words. Female. Which one of you are going to write more in your book, science or scientists? Male. I do want very much to write something about science, actually, so I prefer to scientists. Female. All right. What's interesting in scientists, then? Male. Science is just like complex furniture, which is all about evidence. But scientists can tell stories, do researches, and propose questions to find what is true. They are like a focal point. They are always in interesting situations. Female. Whether science or scientists your book mainly about, It seems to be rather hard for general readers to understand, doesn't it? Male. I don't think so, really. In fact, the book I write in is science fiction, which is related with science but is not strictly scientific. So you don't have to have a PhD degree in physics or other disciplines to understand a science fiction. And loving science is very different from being a scientist, which means fiction writing is not the same as writing scientific journals. When scientists fail, they will question the situation about why they have failed. But as a fiction writer, I don't have to. In my book, you can always see stories about happy family.
When Daniel was 13, around 1994, he had recognized the potential of creating websites for the fledgling internet, so he started a small home business making websites for clients. He charged his first client $100,